All right, so today we're doing 1.3, which is the 12 basic functions, and then we're talking about graphing piecewise functions. So we're going to do piecewise functions first and then the 12 basic functions. A note with these, I'm going to go over them super duper briefly in this video, and then there's an activity you can do on Schoology, kind of like the 1.1 activity, where you match different things together, or you can just look them up in the book. If you come to Zoom on Monday the 21st, so if you're watching this early, come to Zoom. If you've already come to Zoom, you already saw this, but I'm going to go over them in more detail. I'm also going to post a Quizlet in Schoology of the flashcards, basically, if you want to memorize them. You will need to have these memorized, so memorize them by the quiz, because you're going to need to know things about them and use them for the quiz. Okay, so piecewise functions. A piecewise function is a function whose definition changes depending on the value of x. So you get a list of different functions. So this one here, if x is less than or equal to 2, you plug it in to x squared. If x is greater than 2, you plug it into x minus 1. So you're taking parts of different graphs and putting them together to make one big graph. This is usually where you get jumps and weird things happening, but it's just defining when x is something. So an example, this is the exact one that was just on the last slide. So we're going to plug this in. We have f of negative 3. So you want to decide, do I want to go into the first function or the second function? Well, negative 3 here is less than 2. So we want to plug it into x squared. So you get negative 3 squared, which is 9. Keep going. Switch colors here. If we have 2, 2 is equal to 2, right? So we're going to go here where we have our equal to and plug it back into the x squared. So you have 2 squared equals 4 for the last one. Right here we have 5. 5 is greater than 2, so you want to plug it into this one. So you do 5 minus 1, and you get 4. And that's just evaluating them. So you just make sure you look at which equation should you plug it into before you actually use it. All right, so actually graphing it. Here you're going to need to make 2 separate tables, one for your x squared and one for your x minus 1. So I'm going to do this one first. We'll make an xy table. And then how you pick your x values, you want to look at this and follow whatever this says. So you want it less than or equal to 2. So you want to start with 2 and then go less than 2. Like that. And note here, because it's equal to right there at the bottom, this 2 is going to have a closed circle. So a closed circle is your less than or equal to or greater than equal to. Open circle would be like this. So if we're going to graph this, I'm going to start at 2 and plug that in. You get 4 for 2 squared. 1 squared is 1, 0, 1, and 4. So we're getting a parabola. At 2, we're going to be up at 4. It's a closed circle. At 1, you're at 1. 0, you're at 0. Negative 1. And 4, you're at 4. 2, negative 2, you're at 4. And then I'm just going to connect this like that. And I'm not going to go past right here with this function, because this function only goes to equal to and it stops. Now you want to make the second table with your x, y. I should label this first one so you can see this was your x squared table. And this is the x minus 1 table. So same thing here, you want to start at 2, but now you want to go bigger than 2. So you want 3, 4, 5, etc. A note here, you still want to start at 2 even though we don't equal to, because I could be 2.00000000000000001. So I'm super duper close to 2, but I'm not actually touching it. So you still want to plug in 2. You're just going to have an open circle at that point. Now take those values and plug them in. So 2 minus 1 is 1, 3 minus 1 is 2, etc. as we keep going down. And now you graph this. So at 2, you're at 1. Remember, you want an open circle because we don't have an equals to on the equation. At 3, you're at 2. 4, you're at 3. 5, you're at 4, etc. And you get this line. And that's your graph. So you want to do each chunk by itself. So take a second and pause the video and try this one on your own. Okay, so again, we have two tables. This will be the negative x squared table. And we'll make this one over here be the 3x table. All right, so for the first one, we're less than or equal to 0. So I'm going to start at 0 and go down. Like that. 0 squared is 0. Negative 1 of negative 1 squared is going to be negative 1. And then negative 4, negative 9, negative 16, etc. So this is here, if I do this in parentheses, you have negative of negative 1 squared. So you're going to get negative of positive 1, which then is negative 1. And then I'll switch. Oh, I should graph this first. You can also do both tables and then graph. It doesn't really matter. We want to decide at 0, are we open or closed? We're going to be closed right here. So at 0, 0, start with the closed circle. At negative 1, you're at negative 1. Negative 2, you're at negative 4. Negative 3, you're at negative 9, so somewhere down here. And we're getting that half of the parabola. And if I switch colors, we're still going to start at 0 and then just go up. And this is going to be an open circle because I don't have an equals to on this equation. So then 3 times 0 is 0, 3 times 1 is 3, 2 times 3 is 6, etc. And I'm going to graph this. So I technically have an open circle right there at 0, but it gets filled in with a purple one, so it's really just a dot. So if you have a closed circle and an open circle, it becomes a closed circle because a closed circle fills your open one. And then at 1, we're going to be at 3. At 2, we're going to be at 6. And you get this line. And that's your graph. All right, so the 12 basic functions. Pause a second and think of as many as you can and write them down. So I'm going to list the 12 you're familiar with. You should have x, x squared, x cubed, 1 over x, square root of x, e to the x, ln of x, sine of x, cosine of x, absolute value of x, and then lastly we'll have on the next slide. So these are all the basic ones. Again, come to Zoom, or you've already come to Zoom, and I'll have examples and graphs of all of these. Otherwise, you can do the activity in the 1.3 folder, or check page 99 in your textbook, and that has all of them listed. But the two you probably haven't seen are these two. So the greatest integer function is int x, and what that does is it takes whatever your value is and rounds it down to the nearest whole number. So say I had 1.5. If I do int of 1.5, that's going to equal 1. If I do int of 1, it's just 1. If you do int of like 2.999, it will give you 2. So it always rounds down to the nearest whole number, which then gives you this step. So it's also known as a step function because it's like you have a person walking up your steps. The next one is a logistic function. So it looks kind of like an S-curve. This is used a lot in biology and other things to model population growth. Just kind of remember that name. So the activity again, this is in the 1.3 folder. You can do it there. That's just a matching. So if you have your iPad, you could bring them both down and like copy and paste, like cut stuff out on Notability to get a whole nice organized sheet of what the 12 basic functions are. Otherwise, you can look in your textbook. It's just not laid out as nicely. And then your assignment is on Schoology. This might be accurate, but check Schoology just in case. And that's it.